Okay, everybody, today we're going to look at a rack reset using stall detection. Some of the teams have already figured out the extent of the XY axis on the rack, but there's a little bit more efficient method of actually stopping the rack. Um, the code will be a little bit quicker and a little bit more repeatable, so let's just jump right in. I have the same RoboKai robot that everybody else has. Again, the sensors and motors may be in a different spot, so you'll have to apply this to your specific robot. All right, so I've created a base program called rack reset, and the idea is that we get this into a consistent spot always. This rack as we're driving. It was a big pitfall for our 8th grade team last year, and they wasted a lot of time. So this is a pretty important strategy when doing everything. So I'm going to start by doing a left rack reset with motor stall detection. So I'm going to create a my block. I'm going to call it rack left. And we don't have to put any inputs in here because it's just going to perform a function for us. So zoom in a little bit so everybody can see better. So rack left, I know my x-axis is my C motor. So as a best practice here, we're going to put some motor blocks out here. The first thing I want to do is reset the degrees counted on my C motor. And the reason we do this is because after the program runs, these degrees up here are going to change all the time. Every time we come through here, we want them to start at 0 so we can measure our total distance that it's moving. We're going to also set our speed. The program works very, very well, so I have no problem going to 100 on the speed. We want our rack to get where we want it to in a reset as fast as possible. Maybe when you're on the board, if we're doing some rack movements, you may slow some stuff down in order to have some more reliability on something. And then we're also going to set the direction of the motor we want. Since we're only working with a left movement, I've already checked this ahead of time. You need to play with this yourself, but mine's going to be counterclockwise for the rack to go left. When you see the camera, it's going to be facing the robot, so everything could possibly look a little bit backwards to you, but I always do things as though I'm sitting in the robot driving it. So a rack left would be as you're facing the rear. This would end up being the left. You can do what you want as far as counterclockwise or clockwise. And the point of this is really about the stall detection. So I'm going to do something here real quick and go ahead and put in the stall detection block first because I want to show you guys something. It's going to be a wait block. And what we can do is all these motors do have encoders in them, is we can check the motor and see when it stops moving basically. And the way to do that is to get one of our let's see, it's going to be an equals block. So, okay. We're going to get one of these blocks, which is basically a true-false block. It's a Boolean block. So this is going to wait until this situation becomes true. So what we want to do is basically check the speed of the motor and look for 0. So this block right here will continue to run until the motor gets to 0. You can kind of see what's about to happen here. By doing this, you can't jam your rack, and this is where it becomes powerful. We used to kind of do wait until the motor stalled or you've reached your final limits, but the code works so good inside Scratch that the other part would kind of be redundant. So it's just as easy to make the rack go all the way to the side and stop. So basically I'm saying you just keep going until you hit the edge. And then at the end, another good practice, we're always going to stop the motor. Now with this kind of code, you should never get a hang up. As you guys saw in class, when your rack hit the edge, your program stopped and it sat there and it waited for it to finish. And you basically are going to stick your robot on the board and you're going to be in big trouble. Now this looks like it would work. Now I'm just going to pull this over here and run it real quick so you can see it. And got to do this obviously. So I'm going to do a rack left in here. And again, let's keep our best practices and exit some programs. All right, so I'm going to run this. And you see it did nothing. Well, that's a little bit interesting. Why did it do nothing? The program is so fast coming through here that by the time it got to this block right here, the wait block, it saw the motor at 0. So because the motor never started moving, this condition became true and it stopped the motor. So how do we get around this? Well, the best thing to do is put in just a tiny wait here. So basically we're going to start the motor up and then we'll wait just a little bit before we start checking to see if it jams. And 0.1 is fine. This thing, like I said, it's so fast. I've run these 40, 50 times at these intervals and I did not have a miss. So we're going to go ahead and run a rack left. Now, again, there's no distance here. So as soon as the rack hits the side, we should be stopping. And there it is. Worked perfectly. Even if I tried to run this code right now when it's already left, it's still going to work. See, it's done. It finished. It detected 0. It's very reliable. Now, all we need to do is duplicate some stuff here. So let's make another my block. Call it rack right. And ultimately what we're trying to do is get this guy into the middle at the end of the day in a reliable spot. So put this up here. I'm just going to pull the camera off for a second so you can see my code. If you want to be clever, we can probably duplicate all this like so. And all we'd have to do is change this to clockwise. So now we got a rack left and a rack right. We can go ahead and try the code. Should hit one edge and then go hit the other edge. And I'll run it one more time just so you can see that it did indeed go left. Okay. So now all that's left is to do the exact same thing on the y-axis. I'm going to do it quickly here, and then I'll add one little piece of code at the middle to get this back into the center. So I'm going to pull this off for the moment. Give us some space. Do the same thing again. So I'm going to make a block called, we'll call it rack up. I'm going to go ahead and make the block for rack down also too. Okay. Put these guys down here. A little bit of housekeeping. Okay, I'm still going to duplicate even though this is a different motor. Mine happens to be the D motor for all this stuff, so we'll have to make some changes here. And I've already figured out my clockwise and counterclockwise. My rack up is actually clockwise, but these all need to be D. Okay, and then we'll copy this because it'll be a little bit faster. And then we simply just need to change this to counterclockwise. Don't worry if I'm going fast. You guys can digest this. I know we looked at it in class too, and I know some of you already have some of the code. So we'll do rack up, rack down. And again, the reason I broke these up was specifically in case I wanted to go rack left or rack right in my program. I'll show you how I combine them at the end. So let's take a look, see if everything's in place. There's our left, there's our right, there's our up, there's our down. Okay, and we're sitting there. Now, what I like to do is make a rack middle. So a home point so that my robot's in a consistent spot every time. So I'm going to call this rack mid X, which means I'm putting the X in the middle after reset. I'm putting after reset in here simply because this code would not work if it was in a different spot, just this one block by itself. So it relies on the fact that these blocks have been run right here. So we'll go ahead and do this real quick. So I know it's C here. So actually, I'm just gonna make a quick copy of this because we pretty much always want to do this. We always need to reset our degrees counted and our speed. This block is not going to be here though. So Now, instead of just running in some direction this time, we're going to go a certain distance. I've calculated that it's about, I would say 620 degrees. Some of the kids have already done this exercise, the students have. They knew how many rotations it was to move this. In my case, since I kind of want to go back to the right, we need to go counterclockwise. I'm sorry, back to the left because you're facing the camera. So we're going to do a motor block here, and this time we're going to go for a distance too. So we're going to run the motor with that and for distance. So let's see what we got here. So start motor, 4 rotations. Okay, here we go. So we'll be able to tweak this block here a little bit. I'm just going to pull him in so you can see him. I know he's on top here, or I can slide over. So like I said, it's about 620 degrees. So you would think 310 is the middle. My robot's a little bit slow, so you have to sit there and play with it yourself. Your value may be different, but I know the middle is about 340 degrees for me. And we're going to want to go counterclockwise because we're moving the rack left. Okay. And there we go. That should get it right back into the middle. Best practice again, we'll always stop our motor. And now let's add that in, which is going to be a put me in the middle type thing. So it should go left, right, up, down, and then back to the middle. Okay, so let's take it for a test drive here real quick. There's your edges, there's your high edge, there's your low edge, and there's your middle. I try to line it up off of these tires in this location right here when you're looking at it from the front. Maybe off of this spot up here. It's black, it's hard to see on the camera. But you could mess around with that. I didn't have this out here. Let me run it again with this out here, I'm sorry. There's your left, there's your right, there's your up, there's your down, there's your middle. And what I try to do is line up right here is what I was showing. So based on what you set this value to here, this 340, if I make it more or less, you'll be able to figure out where your X is going to end. One last thing I like to do, because this gets called very often, is make a full rack, because when you come off the board, you don't want to have to put this code in every single time. Haven't really done this before, but you can put my blocks inside of my blocks. So let's just call it full rack. This will ultimately be your home position coming off the board. And then we're basically just going to take all this code we just did, blocks wise right here. I'm just going to do that and pull this guy back over. Okay, and then we'll pull full rack out here. So that should do everything all at once. We'll have a nice little rack reset program that's very consistent and should put you on the way to reliability on every run. So now we're down to one nice block here, and there you go. And that does it. That should be it for this. I can't think of any other gotchas. The code's reasonably straightforward, and that's it. Thank you.